Hi, Honors Math 9. Today we're going to do some compound interest. Have fun.
All right, Honors Math 9, Section 5.5, Exponential Growth and Decay. So today we're going to talk about kind of 2/3 different equations we're going to talk about for exponential growth and decay. So the first one, I just want to remind you, exponential function is y is equal to a times b to the x. And the base b, that's going to be called your growth factor or decay factor. And it's going to be 1 plus or minus the percent rate of change expressed as a decimal. Awesome. And then we know that A is the initial amount. It's also the y-intercept when x is equal to 0. So that's cool to know. So the basic equation that we're going to use for the exponential growth and decay model based on this information is y is equal to a 1 plus or minus r, depending if it's growth or decay, to the power of t. And t represents time, r is rate, and a is your initial amount. All right, so a word problem that goes along with this equation is since 2005, the amount of money spent in the U.S. has increased by 7% each year. In 2005, about $360 billion was spent. So that's a little bit of background information. The question, if the trend continues, how much will be spent in the current year, which is 2020? All right, so let's go back to the word problem, and I'm going to underline some key information. 7% increase. So if you're increasing something, that means you're adding it. And it started off with $360 billion. So we're not going to write the 360 billion with all those zeros. We're just going to use 360, and then our label is going to be billions of dollars. All right, so if the trend continues, how much will be spent in the current year? So let's use the equation. Since we are increasing, we're going to use a 1 plus r to the power of t. We know our initial amount is $360 billion. The interest rate, remember when you go from your percent, you move the decimal 2 places to the left, 0.07. And how many years is it from 2005 to 2020? 15. So then when you enter that into the calculator, you should get about $993 billion. There you go. All right, the next thing we're going to talk about is called compound interest. And compound interest calculates the growth of an account with interest over time. The most common use of compound interest for you guys would be your savings account. I know I have a savings account through Country Bank, and they calculate an interest every month for me. The equation is a is equal to p 1 plus r over n to the power of nt. And all of these variables mean something. So a is your ending amount, p is your principal, which is also called your initial amount, r is your interest rate. Remember, when we use the equation, we always represent the interest rate as a decimal. N is the number of times compounded, so sometimes you can compound it quarterly, which would be 4 times, monthly, which would be 12, annually, which would be once, semi-annually, which would be twice, and t in years. All right, our example 2, talking about compound interest. Suppose that when you were born, your parents invested $2,000 into an account that pays 4.5% compounded quarterly. So again, some background knowledge. Question, how much would be in your account after 18 years? So going through this problem, I'm going to underline some important information. We start off with $2,000. That's how much we put into the savings or into the account. Our interest rate is 4.5%, and it's compounded quarterly. We want to know how much would be in our account after 18 years. So again, we're going to use the formula. A is equal to P 1 plus R over N to the power of NT. We don't know how much we're going to end up with. That's our question. So A is equal to, P is the principal or initial amount. In this problem, the initial amount is $2,000. 1 plus our interest rate is going to be 4.5%, so written as a decimal, 0.045. N is the number of times compounded. Since it's compounded quarterly, that means it's going to do it 4 times. To the power of n, which is 4 times, if you're born to 18 years, you have 18 years. So when you type that into the calculator, you should get $3,421.68. And this time, because we're talking about money, you want to round to 2 decimal places. Nice job today, guys.